Hi guys, welcome to another session of Starknet Kampala Basecamp. And the whole lesson of the Basecamp is to onboard many developers onto the Starknet blockchain. So in this session, we are going to look at generic types and traits. Every programming language has tools for effectively handling the duplication of concepts. So first and foremost, you can follow our previous sessions using the central code. We have a playlist of all the sessions we've so far covered as part of our Basecamp. And our Basecamp is ending in September. Yeah. And this is going to be the last session handling the Cairo programming language. The next session is going to usher us into the Starknet smart contracts. Every programming language has tools for effectively handling the duplication of concepts. So I'm benchmarking the book.cairo.org, the official documentation of the Cairo programming language. So in Cairo, one such tool is generics. Abstract stands in for concrete types or other properties. We can express the behavior of generics or how they relate to other generics without knowing what will be in their place when compiling and running the code. So generics allow us to replace specific types with a placeholder that represent multiple types to remove code duplication. So the whole essence of generics is to minimize code duplication. And in case you have to follow the documentation, there is a lot of literature right there, but I'm not going to go into it. I want to go to the practical session about generics. So we use generics to create definitions of item declarations such as structs and functions, which we can then use with many different concrete data types. So we use generics when defining functions, structs, enums, traits, implementation, and methods. So now let's go ahead and see generics in practice. So I'm going to have a practical application. So let's start a new project. I'm storing all my projects under the Cairo programs directory. So I say to start a new project by saying scab new. We can call it generics new. That's how we start a new project. I'm going to use the defaults. Then I'm going to change directory to generics new. Then I'll activate VS Code. Let me close some. So I've activated VS Code, and as I said, these are the default files that come along with it. We have the lib.cairo, we have the scab.toml. So let's create a new file here, and let's call it generics.cairo. We're calling our file generics.cairo. So I'm going to write a function, and it's going to return the smallest element from an array. Yeah, but it's going to handle a case where we are going to implement, since we can have custom types. Yeah, so you're supposed to handle the types using generics. For example, if I told a function is having a custom type, and maybe the array at some point is going to drop out of scope, the type is as well supposed to drop out of scope, but we're supposed to tell Cairo how we are supposed to tell Cairo that the type is supposed to, we're supposed to handle the case where the data type which we are basing on for our data in the array is going to get out of scope, but we are supposed to handle that using traits and then generics. So let's write our function here. Find the smallest element. So we are using the t partial odd. Now the partial odd is also a trait which helps to handle comparison. Yeah, it helps to handle comparison. So we are using it in our generics here. So let me first write, then I'm going to explain what is happening behind the scene. So let me explain just in a few seconds. So I'm having a function, and this function, it's having a generic type. It's having a generic type t. Yeah, it's having a generic type t, and it's returning, and it's as well returning the generic type. Yeah, since I said our function is finding the smallest element, that's why we are attaching the partial the partial odd trait. Yeah. So when you're handling a generic type, you have to, after the function name, you have to add the angle brackets, then you add in the type, then you as well add in the traits. Yeah. So we are going to use the copy trait and the partial odd trait. So why we use the copy trait? It's because we are using a snapshot, and we're using a snapshot and need to copy. So that's why we're using the copy trait. In our previous session, you will, if in case you have to go back in our previous session, is where I talked about where they use a clone to copy something, and then where you can use a snapshot. So in this case, we are using a snapshot, but every time you're using a snapshot, you have to use the copy trait. And then another trait we are using, so every time you have to declare a trait on a generic data type, you have to add the implement. You have to first add the implement keyword, then the name of the trait, and then the trait. So then as well, we are using the drop trait because in case the array gets out of scope and then the generic data type gets out of scope, we have to drop it. And then after that, you add in the parameter. So the parameter is taking in it's a list, and in this case the list is a snapshot to the array, and then the snapshot to the array as well is referencing, it's basing on the generic data type, and it's returning this generic data type. So after that, we want to first we are declaring that the smallest element is equal to the first is equal to, so this is a statement where we are saying the variable smallest, let it be the first element in the array, in the list array. I want you to take note of how I'm using the snap operator. Yeah, as I said, every time you're making a snapshot, to get the element in the array, you have to use the snap. Yeah, so then another one, we are making another statement which is creating a mutable, a variable which is mutable, and that's index. Yeah, so then while index is less than list, so we're trying to use the while loop right here. So we want to loop, and we are basing on the length of the array, and to get the size of the array, that's why you say, remember the last element in the array is always the total number of elements in the array minus 1. So we are trying to loop over elements basing on the length of the array. So right here we say if, as well, we are using a snap operator to get the, and to get any elements in an array, you use the array name, which is in this case list, and then you use the index, and then, but remember, since this is a snapshot, you have to use the snap operator. So we are basing on the index to loop over our array. So smallest, so you can first follow along. So index plus 1. So hope our loop is clear. So first, of course, we are having a condition. If at all the index is less than the size of the array, yeah, we have created another variable here, and we had already created the smallest variable, and now we are saying we're shifting ownership, because initially we had initiated it as being the first, yeah. Now we are basing on the size of the array to loop over the array, and we are going to loop over every element, and then by shifting the focus of the index, that's what will help us to move to the next element in the array. So then after that, we return the smallest. So then we have another thing right here. So that was just a practical implementation. That's an implementation of a generic. So I want us to see how we're having a generic type T, and then T. So in case we didn't need to implement the partial odd trait, we didn't need to attach it. But in case we need to, in case you're making comparisons, maybe you have cases where you're saying A is equal to B, A is less than B. You have to use the partial odd trait. So that's how we have to implement it. Use the implement keyword, and then also we're using the copy trait. The copy trait, we are using it because of a snapshot, and we're using it to copy things we're using the snapshot to get as a reference to get the elements in the array. And then the other trait we are using, as you can see, is the drop trait. We are using the drop trait because as the array gets out of scope, we as well have to let the compiler know that the next trait has as well gotten out of scope. So then let's proceed with the documentation. So until now, we have specified the name for required generic traits. So we have the T partial odd or partial odd traits, T drop for drop, and T copy for copy. However, most of the time we don't use the implementation of the function body. So implement something right here. Now, since in most times you'll find that we don't need to, so we don't need to use everything in the function body, since we are not using, so we want to we want to simplify it by removing the implement keyword, and we simplify it. Let's write another signature of the function right here. So let's first comment this out by using forward slashes. Yeah, smallest elements. Yeah, and then right here we add in the generic data type, and then by using the plus partial odd, it helps us not having to add the implement keywords. Yeah, so, and then as well for the copy trait, you don't need to attach the implement keywords. And then as well for the drop trait, so this is a simplified signature as compared to the previous one. So then you add in the parameters, so it's taking in a list, which is a snapshot to the array. So it's right there. So that's our function. Yeah, so you can see it's a bit simplified compared to the previous one. You don't need to attach the implement keyword. So now let's go ahead and look at structs. The structs we can also define as those structs to use generic type parameters, yeah, for one or two fields, yeah. For example, in case I have a struct and my struct is having field elements, and these field elements each has a different type, generic type. So I'm supposed to handle that. So how do I handle that? Let's follow the documentation. And so in case I have a struct right here, yeah, and maybe my struct, let me give it a name. Maybe it is my wallet, yeah, and it has the field elements are basing are using this generic data type, yeah. So since my struct can get out of scope, so I'm supposed to attach the drop trait to it, yeah. So then here I have my main function. So in my main function, it's an instance to a struct, yeah. Then I can just say, since I only have one field element, I can just say that my balance, probably it's 2, yeah, and that's that, yeah. And then as well I can have 2 data types. For example, in case my struct has another field element right here, and then the field element has another generic data type, yeah. So I'm supposed, for example, in case it's called number, field element, and I'm supposed to add that generic type to the struct after the struct's name, yeah. So it's as simple as doing that. Then I just say number 20. That's how we can add generic data types in structs. And then we can as well have generic data types in enums, as we saw previously. How we can use the option enum. So I can have my enum right here, yeah, and then my enum is, remember we said that enum has 2 case scenarios. It helps us to handle 2 scenarios where the first scenario is returning some data, and then the other returns a case where it's none. So some, then spacing. So what is returning? So the data, what is being returned is being returned under a sum case, and then the other case is none. Yeah. So it's as simple as that. So you can see we're using generics to add the generic data type to the option. Another case scenario is where you have a result. Now we are going to look at result in details, but let's go ahead and look at generic methods. Yeah. So just like, because you've constructed a struct, yeah, you've constructed a struct and you've given it generic data type. So even in your in your methods and in your traits, you're supposed to handle the generic data types of that struct. So in case we have our struct right there, so it's, we have to attach the copy trait and then the drop trait. So I want to create a trait, so wallet traits, and the generic data types are T and V. Yeah, and then right here, one method is helping me to return the balance. And remember, when you are creating a method, you have to, the first argument is a self, and then it's taking in a snapshot. That's why we need the copy trait, because we are having a snapshot. Yeah, and it's returning the generics. Yeah, the generic data type. And then the other methods I can add is returning with number. So remember, all the field elements are having different generic data types. Yeah, so the name of my struct is my wallet. So even here is supposed to be my wallet. My wallet. And then for the number, we're interested because the field elements all have different generic data types. So for the number, it's V. Yeah, and it's returning V. So after creating our trait, a trait is like an interface in languages such as TypeScript. So now to make our traits visible, we have to add them in the implement block. We have to use the implement keyword. Yeah. So then you add right here. You add right here the generic data types. Yeah. And then also you add any traits in this case, since we are having a snapshot in our methods, we are using snapshots, so we only need to attach to use the copy trait, because we don't need to use the drop trait right here. So and then you add in the data types, so we're having T and V. Yeah, right there. Oh, well, so after this section, we are going to look at of this very video. After this section, in the next few minutes, we are going to look at traits. But this is a good introduction to traits. So you can see that I have to first declare the generic data types, and then I as well have to, because we are using the traits and we are using the copy trait, and the copy trait is working for both the balance and the number, and the balance is using the generic data type T, and then the number is using the generic type V. So then we come right here. Now we define our balance method. I said for the method, the first argument is a self argument. So it's returning the balance, yeah, and after right here by getting the number, yeah, we're having right here we're benchmarking the my wallet in our generic type right here, yeah. So in this case it's returning the then after creating an instance of abstract, we want to assert that we want to assert something right here. You can say w dot balance, because w right now is the object, so it's talking to the self. But since it has a method called balance, so we can say balance is equal to 2. And as well, we can create another assertion to test the number. Yeah, we can say w this number is equal to 20. So we are going to run our code to see whether our project is running as expected. As I said, we have to come and change right here in the lib.cairo because it's the root file. So when you are calling in the module, generate, so we are having an error right here. It's saying my wallet installing has failed to infer. Type annotation needed. So let's try to debug why are we getting that error. So my wallet trade right there, that's correct. Okay, so it's telling us type annotation needed, failed to infer. Okay, what could be the error? I'm having my error right here. Having an error right here, and I was not good. But through debugging errors, we learn to grow our knowledge. It helps us to understand what we're not doing right. So telling me type annotation needed with something to do with the generic type. Yeah. First, my trait is well and good because my generic traits are T and D. Yeah. So let me click here on the problem. Type annotation needed, fail to infer. So let me check this out. Trying to debug. Okay. Going to debug, do some debugging right here. What happens if I going to do some debugging right here and follow along. I'm still getting an error, still on the struct. Still getting an error, failed to infer. We can look up that error using Google. Failed to infer. So you can always use Google to check up in case of any debugging. There's something which we are not doing right. Something we're not doing right. What could that be? What could that be? Let's first try to, because in my struct I had handled two data types. So let's use a case where we only have one generic type and probably sure I still get the same error. So in case I have one generic type, here we see that my error is reduced right here. Let me first handle the case where I'm having one generic type. Let me first maintain one generic type right here. You can see that I no longer have many. You can see that I don't have many errors right here. Let me first move this. Let me first handle this case where I have one generic type. Yeah. Then let me run. So I run my code by saying scab Cairo runs. That's how I run. So let me run my code, and then I run my code by saying scab Cairo run, as you see, and then it has returned me. It has not complained. That means it has asserted that everything is working correctly, basing on the assertion I made. So the assertion I made is that assert that the balance and the balance method is returning the balance. So assert that the balance, yeah, of the my wallet struct is equal actually to, and it's 2 because it's what I initiated. So in case I change here and see what we are going to get, we are going to get an error because so let me try that case where I've given it another. I change the thing in the assertion. So running my code again. So you see that the assertion fails. Yeah, the assertion has failed because I constructed my wallet struct with a balance of 2, and I'm here asserting that the balance is equal to 4, so it has to fail. Hopefully we've gotten that. So that's how we can use generics in structs. There are other examples right there if you follow the documentation. Yeah, but let's go ahead and see how we can use traits in Cairo. So we've talked about traits, but how do we actually use them in Cairo? Yeah, so we are going to have, in this section, we are going to look at traits extensively. So once again, a trait defines a set of methods that can be implemented by a type. These methods can be called on instances of a type. When this trait is implemented, a trait combined with a generic type defines functionality. As you've seen, we've been using a lot of generic types with traits. Defines functionality of a particular type. Functionality a particular type has and can share with other types. You can use traits to define shared behavior in an abstract way. You can use trait bounds to specify that a generic type can be any type. So remember I talked about this. Traits are similar to features. A feature often called interface in other languages. Languages like TypeScript, where we use interfaces, and you can see that if at all you've written TypeScript code, you'll see that the syntax of interface is similar to the syntax of traits. When traits can be written to not accept generic types, they are most useful when used with generic targets. So let's see how we can define a trait. As well, we are still following the documentation. Yeah. So let's define a trait. So let's create a new file and let's call it traits. My traits. Cairo. Yeah, and this is how we construct, we create a trait. So I've started by using the pub keyword. When I say pub, that means an external module can utilize it. Yeah, but when I don't add the pub keyword, it means that it's private. So under here I have a method which is called summarize. Summarize is a method, so it has to have the first parameter has to be a self keyword, and then it's referencing probably an extract, which is news article, yeah, and it's returning a byte array. Now we use byte array to represent strings in Cairo, long strings in Cairo. As you can see the note that byte array is a type. Byte array are used to represent strings which have more than 31 characters in Cairo. So right there, and then so in case we are not following so we can write a more generic trait right here to handle any generic type, and to do that we are going to add a snapshot to the generic data type rather than attaching it to only one specific struct. So we have made a change right there. So now the next session is how can we implement a trait on a type. Yeah. So let's create a struct right here. Of course, our struct, since it can get out of scope, so we have to attach the drop trait to it. Yeah. Let's create our struct, and we are calling it a public struct, and we are calling it news article. And right here, so the difference between an enum, so every time I declare an enum as public, I don't need to add the public keyword to every element in the enum. But for a structure, I have to. The only way I can make the elements as well public, I have to attach the public keyword, yeah, on the individual elements in the struct. So public headline, and write here byte array. So then another element of the struct is location, and it's as well a byte array. Then another one is an author. An author is well a byte array. So the an author is the name of the author. It has to be a byte array. And right here we are having the content as well. Since content can have a lot of can be long strings, so it's as well a byte array. So then I said when you don't add the implement block on the trait, your trait won't be visible and you cannot use it. When you use it, it will return an error. So right here summary, having this article right here. So now we are under the implement block is where we define our method. We are having a summarize method. First it starts with a self keyword, and it's taking a snapshot to news article, and then it's returning a byte array. Yeah. And then we use the format macro in case we want to return data in some way. Yeah. So guys, I'm following the documentation. So self dot right here, I want to return headline, and self dot author, and self dot location. And then we are having another struct as well. So in our trade right here, it's taking in the news article. Then I'm having another struct right here. Yeah. Using the trades, I have to attach public struct with like array. Add another field element, add another element in this part. I don't think they're really field elements, but it's just an element in it. I can call them attributes. I can use a similar analogy in Python when you're creating classes. Yeah. So the attributes are like the properties of the class. So that's similar to that. So I think you can call them attributes. Now as well, I'm having another attribute right here, recruit, which is well a boolean. So I've declared my struct right here, and then you can see, as I said, we have first created our traits. Let me copy this and put it above the implementation block. So after declaring your struct here, constructing your struct, creating a struct, and now you can see it's public. So every attribute in it is public. And then you construct your traits. As I said, it's an interface. So understand, when you're constructing a trait, it's like you are declaring. Then after you define the trait and the method in the trait using the implement block. So now we are having the implement block, and we are implementing the trait, but it's basing of the news article struct. Then come here, you define your, after that you come and define your summarize method. So it's just as simple as that. And then you can come and check out, you follow the documentation, you look at something that is having managing external trades. I'm not going to go in details with them. Nothing really changes a lot there, but in the documentation you can follow. So I'm going to go into something called error handling. So in error handling, we have seen things as using the option in using the panic. Now in error handling, if at all I've used, as you can see in the documentation, that here they are using the panic. Now what panic does is that it immediately stops execution of the program and it stops. But that's not what we want. For example, you don't want your program to terminate immediately. You want it to find a way of handling the error. Yeah. So that's what a panic macro does, but it's not good. It's not good to use it unless you are using it in maybe in a case scenario where you want your program to terminate immediately. But it would be better to use an option enum. Yeah. So that's it with error handling. And this is what the enum, so the result enum, so recoverable errors will result. So most errors aren't serious enough to require a program to stop entirely. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you try to add two large integers and the operation overflows because the sum exceeds the maximum representable value, you might want to return an error or a wrapped result instead of causing undefined behavior. So as I said, sometimes you don't want execution to stop there and then. You want to continue with other, you want the compiler to run other bits of your code. So that's where the result enum comes in handy. So you can as well use trace with the result enum, and if you follow the documentation, you will see how to use trace, as we've introduced trace in some few minutes back. So trace can as well, generic trace can as well be used with the result enum. So I'm going to go in our last section of this session, and that's something to do with testing. Yeah. So probably we've seen that when we are initiating our project, there is always in the lib.cairo file, there is always that bit of testing code. So of course, as we all know that any program, any package, maybe if I write a package, my package is perfectly handled if at all I can test code. Yeah. So in case you've written code which cannot be tested, that means your program is good for nothing. Yeah. So in case you're from a Web2 background, you have been having what is called test-driven development. Yeah. So your first in test-driven development, you make sure that everything you've handled a test for it. Yeah. Because you don't want to have cases where your code is stopping to work because you didn't handle a perfect test for it. So let me add a sample test right here. So let me create another function, another module, and call it test.cairo, and under it, and in this module I can add a public function. Let me call it add, and this takes in, I'm following the documentation guys, it takes in the left parameter, which is just a size, a defined size, and then as well the right, which is a use size, and it's returning a use size right here. So it's returning left plus right. Yeah. So now I just want to write a simple test right here. So when you're writing a test, we have to add the config to show Cairo that this is a test. Yeah. So then I can go ahead and write my code here. So I can go ahead and write my code here, mod test. Yeah. And then I add, so every test which is under this test, so I'm declaring my test and declare this is the test. I have to first start by writing the hash and then the test in those square brackets. And then I add my test right here. I'm testing if it works. So the first test function I'm writing is called it works. Yeah. And I'm posing a statement right here and I'm saying let result equal to add to 2. And then I'm using the assert equal. Yeah. So my result is supposed to equal to 4. So that's a simple test right there. And when I run, it's supposed to run properly. So I come and change here. I change this to test. As simple as that. Yeah. Oh yeah, I have to when you guys will call the super keyword. So the super keyword gets a it can get a structure, it can get a function, it can get an enum from an upper level. So in this case, remember I've declared that I'm declaring a module and it's called test. And the add function is not in the scope of the module. So I have to use the super keyword to get it from a scope from a higher level. So then I'm supposed to run and my test is supposed to not return an error because my result, I'm adding 2 numbers, 2 and 2, and it's supposed to return me 4. So let me run my code right here. It's supposed to compile correctly without any errors. So my code is compiling. Yeah. So I have an error right there. And my error is that I don't have a main function. So my error is complaining. My program is complaining. So let me create a function, a main function here, right here. So I'm just going to make some few adjustments. I don't need to use the super keyword right here. I can just simplify it by doing this. Let me add everything in the main function. Yeah. Still I'm having an error. because this is I've written it badly. So this is supposed to be like this. So I've added everything in the main function right there. Let me just make a small adjustment here. Okay, so I've made an adjustment right there. Okay, let's do it in this way. Let me call this, let me give it a name, testing, yeah, and then after that I have my driver function right here. So I've written my function and I've called it, I've written a function and I've called it, testing, yeah. So my compiler is warning me that I have an error. So but then right here I can call the testing function. Yeah. So I don't need to add all this. Let me cut this right here. So I don't need to add the super. But there is a simplified way I can do it. Yeah. I don't need to add this test. So I can just let results, yeah, equal to that. And then right here I can just assert. We shall see that testing is more about using the assert equals, asserting. But then right here, so when you're writing tests, if you follow the documentation, you will see that here I'm handling a case where so let's first return this and see whether my code runs as expected. Yeah. So it's saying function not found. Why is it saying that? So I'm having an error. Consider by ignoring okay. I'm having an error right there. So in the lib.cairo, I called in my test. Yeah. Now let's look at a simplified example. So, but if at all you control the documentation, that's how they write tests in Cairo. And that's how we are going to be writing tests. And mostly tests, you will find that if you are to check out in this, if you are to check out in the documentation, so this is how you write test. Yeah. So this is how you write your test. Yeah. First, you have to, when everything that proceeds under this config and then the module, so everything which is under the module, the mod test is a test. Yeah. And now the functions, the test functions are supposed to be after that test keyword which is in the square brackets. And some of the functions, for example, here it's fn, it adds to, and then we are asserting equal. We are asserting equal for add to. So add to, and then we have to give it the arguments. It's taking in a 2. But we have to first define the function. So it's a public function right here. And the public function is called add to. Yeah. And it's taking in a parameter, a U32. And then it returns a plus 2. Yeah. So guys, tests are more about using the assert keywords. Yeah, that's mostly what is about tests. So we are asserting equals that the add to function, add to function is so the function is not seen right here because I have to first add it in this scope by using the use super keyword. So by using the use super keyword, I've added it in the scope of the module, the test module. So guys, tests are more about you doing assertions. The things are more about doing assertions to things. When you're asserting, you're testing whether this equals to this. So that's what tests are about. And you will see that in tests, this is very crucial. Everything that has to be in a test, when you are creating the test module, you have to configure the tests. Yeah. And then under the module, remember the mod keyword represents that this is a module. And then the functions which are where the assertions are going to be are under this. First is the test keyword. So that's where the assertions live. So that's it with tests. You can guys continue, but of course as your project grows big, you have to organize your tests in modules. So we shall have, when we are handling a project towards the end of our Basecamp, we shall handle a project and we shall look at how we can organize our tests because we shall have multiple modules. So guys, that's it for today's session. Thank you so much for following along, and I'm sure we've quite learned a lot of Cairo. And in our next session, we are going to look at writing smart contracts on Starknet blockchain, and us understanding Cairo is really fundamental to writing logic in our Starknet smart contracts. Thank you so much, and let's keep it strange.